Okay, this is going to be 4-5, and most of the problems in 4-5 are word problems, so I might do a series of short videos where you do each word problem because they can get a little lengthy. They're not difficult, but they can just get a little lengthy. First, we're going to deal with the exponential growth and decay model, which you probably did in Algebra 2, but maybe not this version. So this is the exponential growth and decay model. Let me tell you what each one of the variables stands for. AO is the original amount, and this could be an original population, or it could be the original amount of a substance. E, of course, is on your calculator. It is, it's like pi, but it's on your calculator. It's right above the division bar, I think. T, of course, is time. And K is the growth or decay constant, depending on whether it's a growth or decay question. And K is a constant for that particular problem, meaning if we're talking about how a population of bugs grows, then K will be constant every time you're talking about that population of bugs. If you're talking about the way a bacteria dies, K will be constant for that type of bacteria. But our K value is often what we're looking for. So these types of problems usually have two parts to them that they want you to figure out, and they usually want you to find your K and then use it to find some sort of time. So on this, we're going to use our exponential growth model to model population. So the question asks, find an exponential growth function to model data from 1970 to 2007. Now, they ask me that, and then they give me a table, and let me show you what the table looks like, because you'll probably have one like this on the computer. They give me a table that looks like this. I know you can't really see that. That's okay, I'm going to give you the values. But this first year on the bar graph is 1970, and it tells me the population then. And then here's 2007, and it tells me the population there. So you might have one like that on your computer assignment. So in this case, they've given me the original amount, or the amount in 1970, because that's the first year that they gave me available. So my AO in 1970 is going to be 203.3, and this is in millions. My A value, which is in 2007, is 300.9 million. So I'm going to plug these values into my exponential growth model. So I'm going to plug in 300.9 equals 203.3 e to the k, and my time is between 70 and 2007, so it's going to be 37. Now I just need to solve this. Don't forget, the easiest way to solve this, and which I have discovered, by the way, that the computer does not do it this way, but I think it's a little easier, is to isolate the exponential piece. So to get this piece by itself. So the first thing I'm going to do is divide by 203. And that cancels that out. Now, on my calculator, when I do this, I'm going to get decimals. I'm just going to leave the things in my calculator so that I don't have to round until the end of the problem. So you can see I got 1.480078701. I'm going to leave that value in my calculator and use it here in just a minute. So I have now this value, which I've left in my calculator, equals e to the k times 37. Now remember, I need to get that down on the line. It's up in the exponent. I need it down on the line, so we're going to use a logarithm to do that. And you can take the logarithm of both sides. We'll use natural log because of this e. So I have this value, natural log of E. And the whole purpose in doing that was to bring this value down to the line. So I'm going to move the 37 in front, equals natural log of all of this. Now, if you remember, natural log of E cancels out. So this is gone. I need to get K by itself, so I'm just going to divide by 37. And that's going to give me my growth constant. So remember, I had this value in my calculator. I now need to take the natural log of that value. So I can just arrow up to it and highlight it and hit enter. Or of course, you can always hit the second and negative sign. That'll put the answer in from above. And then divide that by 37. And I get this K value. Now, it's 0.105971. I think they usually say round to 3 decimal places, so this would be 0.011. But again, you can leave it in your calculator. That's my K value. And now, part B of the question asks me, part B, in what year will the population reach 315 million? So now I'm going to go back. I'm using that same growth function, but now I know my K value. So I'm using A equals AOE to the KT. I need for my new amount, this amount, to be 315 million. As far as your AO, you can use either the value that you got for 2007 or the value you got for 1970. I'm going to use that one because I already called it AO earlier. E to the 0.01059K. So now I have plugged in the constant that I figured out. And I need to solve this. So again, we're going to isolate the exponential piece by dividing by 203.3. Take the natural log of both sides. So natural log of that 315. The whole purpose in taking that natural log was so that I can bring that value down onto the line. So this comes down here. Don't forget that natural log of E is going to cancel out. And I can divide by 0.01059. And get your, oh, sorry, this is supposed to have been T all this time, sorry. This is T, because I'm looking for time. Okay, so now when I plug this in, I'm going to plug in natural log of 315 divided by 203.3. And I need to divide all of that by my constant, which I left in my calculator, so I'm just going to go grab it. And I get 41.32, but don't forget the way the question was worded. They asked me, in what year will the population? So it's going to take 41 years. But I have to add that to whatever year I used as my AO, and in this case I used 1970. So I have to add 41 to that. So my year is going to be 2011. And be careful about that on the questions that you're putting in the actual year. Sometimes they ask you how many years does it take, and sometimes they'll say in what year.